If I ask you to solve this Rubik's Cube, what will you do? You might done this, and if that doesn't work, you try another way. If still that doesn't work, you try another way. So this Rubik's Cube can have 7.4 quarter decillion ways that it can go wrong. But there is only one combination that this cube can be solved, right? So you have to try those 7.4 quarter decillion ways one by one to get the perfect combination of this cube. Now let's say if I asked you to try this maze, what will you do? You try one way, and if that doesn't work, you try another way, and if that doesn't work, you try another way. Then finally you end up solving this maze, right? So this is how a normal computer will work. It will try one way, if that doesn't work, it will try another way. So it will try all the combinations one by one. Now, what if I tell you if there is a computer that can try all the 7.4 quarter decillion combinations in minutes and can solve that maze in seconds? And that is
quantum computers.
Quantum computing.
Quantum computing.
Quantum computing is. Or quantum computer. On quantum computing.
Now, quantum computers doesn't work like a normal regular computer like this or this. They have a very different way of seeing things. Let me explain. Quantum computers can solve very complex problems in matter of seconds, where it might take billions of years to solve for a normal computer. But how is this possible? What makes quantum computers so fast? How they can solve these complex problems in matter of seconds? Because you see, a normal computer works with bits, whereas a quantum computer works with qubits, short for quantum bits. So bits are not like qubits. But let me explain the difference between a bit and a qubit. You see, a bit can store a value of 0 or a 1. But a qubit can store either a 0, either a 1, or somewhere between 0 and 1. What I mean to say is, you see, qubit can be a 0 or a 1, or somewhere between that. It doesn't need to be specifically 0 or 1. It can be somewhere between 0 or 1, or it can be 0 or it can be 1. But whereas a bit can only store a 0 or a 1. If it sounds something fancy to you, don't worry, I'll explain you. Imagine there are two lights, okay? So how many combinations that you can try with these two lights? One is both lights on. Is it on? Yes. So both lights are on, and left one is off and right one is still on, and both are off. The fourth one is left side is on and right side is off. So these are the combinations that you can try with two lights, isn't it? So to try all the four combinations, what I'm doing, I am trying one combination only at once. I'm not trying all the four combinations at once. So this is how a normal computer bit will work. It can try only one combination at a time. But if you have two qubits, you can try all the four combinations at a time. So if you still can't understand this, let me explain with a coin. So this is a coin. It can either be a head or a tail. Now if I flip this coin, after it landed on my hand, it can be a head or a tail. Now this is a bit. A bit can only contain a head or a tail. So when I'm flipping it, it's neither a head nor a tail. So only when it landed on my hand, it's being a head or a tail. But what happening when it's in the air? It's flipping, right? When it is flipping, it's neither a head nor a tail. It's being both. So this is how a qubit works. It doesn't need to be a head or a tail like a normal bit. It can be somewhere in the middle. So what's happening when it is in the air? It is trying all the combinations that it can be between a head and a tail. It's not trying to be a head. It's not trying to be a tail. It's trying all the combinations at once. Now in simple words, a landed coin is a bit. A flipping coin is a qubit. Now, okay Andrew, that we understood that, okay, a bit can be a 0 or 1 or a head or a tail, and a qubit can be at any place and it can try all the combinations at once. But how is this useful in your real life? That's what we want. Good question. Now let's come back to our previous problem of solving the maze. So if you ask a regular computer to solve a maze, it will light up and go with one path, and if that doesn't work, then it goes to the other path. If that doesn't work, then it goes to the next path, because a regular computer can try only one combination at once, like a coin, like a bit. It can either be a head or a tail. But whereas a qubit can try all the combinations at once if it have enough amount of qubits. So exactly like a flipping coin, it can try all the combinations. Now let's take an example of an hydrogen molecule. If you want to simulate something like a hydrogen molecule, you need a particle which will exactly behave and follow the quantum mechanics. So if you ask a regular computer to simulate this hydrogen molecule, it doesn't know how to behave like an electron. But whereas a quantum computer contains qubits, a qubit can be an electron and proton, right? Because these qubits follow the physics and follow the laws of quantum mechanics. So it will be very easy to simulate a hydrogen molecule because it can try all the combinations at once. Even if the electrons and protons inside a hydrogen atom keeps on moving, it can try all the combinations at once and it can simulate a hydrogen molecules in a matter of seconds. It's okay, fine. A quantum computer knows how to simulate a hydrogen molecule. But how is this useful in our real life? That's the question. Now, if a quantum computer can simulate molecules and it can behave like electrons and it can behave like real electrons in the world, imagine what it can do. Because this watch is made up of atoms, this book is made up of atoms, the pages inside it are made up of atoms, this mug is made up of atoms, this mouse, this cube, this phone, this pencil, this chain, this perfume is made up of atoms. Everything inside the world is made up of atoms. So imagine the possibilities that a quantum computer can simulate. So it can simulate a perfume, it can simulate a battery, it can simulate a hydrogen molecule, it can simulate other molecules too. So it can simulate almost everything that is present in the world. They can predict how molecules interact with each other, how a molecule will react if it bonds with another molecule. Imagine there is a situation that doctors and scientists are trying to find a cure for a cancer molecule. So to simulate a cancer molecule, it's not easy with a regular computer. Now quantum computers can try simulating a cancer molecule and these doctors can inject 10 different kinds of medicines to this cancer molecule and see how each drug is reacting to this cancer molecule and which one is working best and which one is destroying this and which one is not working as expected. Quantum computers can revolutionize medicine. We don't need human trials, we don't need animal trials. Just using this quantum computer, we can simulate these molecules and we can simulate the drugs molecules as well and can check how these are interacting and which one is working best. Not only this, think of creating batteries. To create an efficient battery for an electric vehicle, we have to understand the molecular states and the internal interactions of how batteries work, how internal molecules are interacting inside a battery. So this is possible with a quantum computer. Now if you try to understand how these molecules inside a battery are trying to interact, we can try making better batteries in the future. Not only this, there is a lot of carbon dioxide inside atmosphere which is more than needed. But if you want to trap or reduce this CO2 inside the atmosphere, you need to understand how the CO2 will interact with other molecules to trap this. Now if you clearly observe, this process of trapping carbon dioxide is done by plants and trees since the beginning of the earth for the process of photosynthesis. Now if a quantum computer can understand how plants are doing this photosynthesis in a molecular way, we can create advanced materials to trap this CO2 in an efficient way. Not only this, agriculture, material science, predicting climate changes, biological mysteries, how universe is working, the options are endless and the quantum computers can revolutionize almost everything that we are experiencing right now. Forget a minute about regular computers. Quantum computers can solve complex problems that take supercomputers billions of years. This is the same reason why many countries and companies are being competitive for achieving quantum supremacy. So the first country to achieve the quantum supremacy will definitely dominate the world. Now let's talk about the design. Why these quantum computers are looking so weird? If it is a computer, where is the metal casing? Where is the keyboard? Where is the mouse? Why is this looking like someone turned a chandelier into a science project? Because quantum computers doesn't need a keyboard, doesn't need a screen, because it doesn't work like a normal computer, because you can't just keep your quantum computer on a desk. We already knew that quantum computers are made up of with qubits, right? So this quantum computer needs to be stored in a very cold place, almost as cold as outer space. And even a small sound or a small vibration can mess them up. They need to be isolated from all the surroundings. So this is the reason they are looking so weird. So it's not just for the show or to make it more look complex. It is needed for them to work. And now to the last question. Will quantum computers replace our normal regular computers? So think a quantum computer is like a boat. which travels, let's say, 100 kilometers per hour. Okay, so no matter how fast you can make this boat travel, let's say 200 or 300 kilometers per hour, can it travel on the land? No, right? So a car is like a regular computer and a boat is like a quantum computer, which is designed for a completely different environment and a completely different use case. So no matter how advanced or fast these quantum computers are, they are not designed for watching Netflix or browsing internet. They are for a very different use case. So these guys are still safe, huh? Quantum computers are unlocking possibilities that once we thought is a science fiction, but now it is no more a science fiction. It is real. They are gonna revolutionize science, medicine, agriculture, technology. They are gonna bleed and channel their efficiency into every aspect of our life. I think quantum computers are amazing, and I hope they are gonna revolutionize how we see science, right? So what do you think about quantum computers? Do you like it? Please let me know in the comments. And you haven't checked out our latest video on how YouTube is handling so much of data, please check out this video. If you found something valuable in this video, please give a thumbs up and do not forget to subscribe. And if you like this video, please share it to your friends. Thank you very much. See you in the next video. Bye bye.